Hello scholars, Mr. Hinkle here. Let's provide an overview of how earthquakes, sudden bursts of energy released in Earth's crust, are measured. So this is what we're doing. We're describing the instruments, and the main instrument is a seismograph. We can see the animation here. We have a weighted pen on a spring that when the seismic wave comes, it shakes the ground, but not the spring or the pen, creating little squiggles on the paper that represent the size, the magnitude of that earthquake. So, a seismograph is the instrument that records seismic waves. And a seismometer, often used synonymously with seismograph, is actually a piece of the seismograph. It's going to be the internal part, which is the pendulum mounted on the spring. So the seismograph is the whole instrument, but this pendulum on a spring is the seismometer, so you can use these two words interchangeably. You might hear someone saying them, and you're thinking, what the heck? I thought it was a seismograph. Or what is it, a seismometer? Well, they're basically the same thing, right? This is the whole instrument. This is the internal pen, but you use them interchangeably. So we've got the instrument recording seismic waves. And the recording that is offered is called a seismogram. Are we picking up a trend here? So the seismogram is going to be the data that is recorded. Seismograph, instrument, seismogram, seismometer, internal part, seismogram, data recorded. And what it's recording are going to be the arrival times of the P waves and the S waves. These are the body waves. And then the arrival time of the surface waves. And if you take the maximum amplitude of the surface wave and the PS interval, then you can use those values in order to calculate the magnitude or how much energy is being released in an earthquake. So, PS interval for this one, 24 seconds. SP time, 24 seconds. Amplitude, 23 millimeters, right here. We connect these dots. We say the magnitude is a 5 on the Richter scale. So this can be done. Current common technique is the moment magnitude system. But for years, the Richter scale was the common go-to scale of measurement for for magnitude. Intensity is going to be looking at the amount of ground shaking. And it uses the information provided by seismographs when an earthquake occurs. Well, you could take seismograph data from 3 points and using the seismogram, calculate the distance from that point to the epicenter. But let's say it's down here in LA. That distance could be in any direction. So you need minimum 3 locations, and where they all overlap, the distance away from the 3 locations, is the location of the epicenter of the earthquake. So where are earthquakes occurring? Well, we can triangulate. Now we have the global seismographic network, 20,000 seismographs all over the world that can pinpoint with very high accuracy the exact location. But before we had the internet and the global seismic network, we used seismographs to record seismic waves and calculate the distance away from that instrument location to triangulate the epicenter of the earthquake. Earthquake magnitude is a measure of the energy released, and we can calculate this from the information provided by seismographs because they're recording the seismic waves that are traveling through and on our Earth. Anything else? We can use this information to determine the location, the epicenter, and then the focus of where the earthquake occurs. So this is earthquake measurement. Thank you so much. I'll see you again.